What is system design? It's easy to say, well, it's the design of systems. But what really is a system? I did some looking up for this. I went on and looked at dictionary definitions and also compared it with my own experience as a system designer. And a system is a set of things working together as parts of a mechanism or an interconnecting network to implement a defined function. In physiology, inside your body, it's a set of organs within the body with a common structure or function, the digestive system. And computing and electronics, it's a group of related hardware units or programs, or both, especially when dedicated to a single application. System design is the process of defining elements of a system, like modules, architectures, components and their interfaces, and data to realize a function based on the specified requirements. It is the process of defining, developing and designing systems which satisfies the specific requirements of a customer. The important word there is customer or user. You need to design systems that satisfies their requirements. So let's look very basically at a system. All systems consist of fundamentally three main areas. There's inputs, some form of stimulus. There is a process or an operation performed on that stimulus, and it produces an output. Now that's very generic. So let's look at some of the systems, and I'm sure some of these you won't expect. Let's look at the commodity, what the function is, and what we would call the system. So commodity, passengers, electricity, money, temperature, internet traffic are all inputs and are all stimulus. The function could be a rail or air network, power grids, a bank or financial institution, a controller, a gain, or measuring the hits. And the system here would be the transport system, an energy distribution system, a food freezer, an amplifier, or indeed traffic control for internet traffic. All of these are systems. Systems is not restricted just to electronic engineering. A few years ago, when I joined the university, I put together a concept called the sensor system. I did this to assist my understanding of what a sensor system is and what happens to data as you sense things. I would recommend you click on the link and read the full paper. It's quite simple and it's explained in a very straightforward manner. But these are the steps that a sensor system stack, as I have defined it, has to perform to change data into information. What is system design and how do we do it? Let's look at a couple of systems, ones that you'll all be very familiar with, before we go in to look at more details in systems.
Son prénom c'est
Bonnie and Clyde. Bonnie and Clyde.
That was fun, wasn't it? I told you you'd recognize those two systems. Now let's look at system design and start focusing in on electronic system design. Electronic system design is all about choice and making decisions on what electronic blocks you require to implement to achieve the desired result and the desired outcome for a customer. Looking back at the two videos we just saw, which car is better? Well, the Nissan is very fuel efficient, it's low in price, it's got luggage space, it can take passengers. And the Mercedes is fast. That's all, it's fast. They're two very different solutions to approximately the same problem. You need to understand what the customer wants to do. But you need to understand what the customer really wants to do with the system you're designing. Whether it's a mobile phone, or a car, or a network, a communications network. You need to understand what they want. In doing that, over the years, there's a very hierarchical and very clear and simple solution for it. It's called the V model. And the V model reflects the processes through system design over time. So at first we start feasibility study, concept exploration, the broad ideas behind it, and then we break down the idea into smaller blocks. We define system requirements, we do a high-level design, then a detailed design, and eventually we end up at a detailed software and hardware design. And then we start integrating the parts together. And defining all the interfaces between all these separate activities. On the left of the diagram, we decompose the problem and define the solution. On the right hand side of the problem, we integrate the blocks from the software and hardware development and recompose the total system to address the customer needs. And at every stage, we have a method of validating and checking to make sure that what we're doing is what is addressing the customer's need. This is called the verification and validation, which we'll talk about later. In the last diagram, showed a generic solution for defining a system to address any problem. Now let's look at an electronic system engineering overview, which reflects very similarly to the generic version. On the left hand side we have customers' needs, what they're going to use it for. On the right hand side we have the delivery of the final solution that you're going to do. And at all stages we break down the problem, starting with requirements capture, all the way down to detailed design. Then we do component testing, all the way up to system functional testing, and deliver the end product. If you consider something as complex as a mobile phone, you can understand why we have to go through so many steps. We decompose and then we integrate. A key step within electronic system design is validation and verification. Validation is checking whether you're doing the right thing. Are you doing what the customer requires. And verification is confirming that you are meeting the specifications. So they're subtly different, and I'll say that again. Validation is, are you doing the right thing? Are you amplifying it by a factor of 10? Are you putting in a DSP algorithm to search for a particular solution? Verification is testing what you've come up with. So let's look at the key steps involved in electronic system design. Here we see the definition and the implementation of a system design. We start with the user requirements at the top, and we work through the specification, the functional requirements, all down, right down to circuit design. And at every level, we have a validation and verification to confirm you are doing what you're meant to do and meet the customer end requirements. So let's summarize system engineering then. System design starts and ends with the customer. You, as an engineer, must understand the application and the use case of the system. It is a hierarchical process, and it's a well-defined process, and every stage relies on the previous stage. So you must take care throughout the process. Validation, or doing the right thing, implementing the right function for the customer, and verification, checking that it meets the specification you have defined, are critical at all stages. So that completes our overview of system design. I hope you found that interesting, and I look forward to talking to you again with some examples of system design and ones that you will try yourself.